Where's mine if you need it? Okay, when I'm looking at this, what was my rule just now? If I've got two things divided together, what am I going to do with their exponents? Minus. Okay, so let's do this with it written out. So C times C, and then C times C times C times C times C. Whoa, no. That's a weird looking C, but you get the idea. What's going to happen with the first two C's? They're going to cancel out. Where do my C's end up?
In the garbage.
In the garbage? Yes? We're on 7-6, next 6. I told you earlier they're old notes. Okay? Where do my C's end up in this fraction? Where do they end up? Look at the screen. Under, in the bottom, right? How many of them are there? What would I write? C to the 3. What about here? What do I write on top? 1. Just to hold that place, not 0. Because 0 divided by something is 0. This is 1 divided by whatever my C is equal to the third power. Right? Okay, very different. Now, what if I use my rule? What was my rule that I just learned? C, and what am I going to do with my 2 and my 5? Rita, what am I going to do with my 2 and my 5? Add them, subtract them, multiply them. What am I going to do? Subtract. And I'm going to do 2 minus 5. Students, stop spacing. 2 minus 5 is what? Ladies and gentlemen, this concept is tough if you don't listen. -3. Okay, here's the rule though. I cannot write any exponents with a negative power. I cannot write any exponents with the negative power. So if I were going to write C to the -3 as a fraction, what would be underneath here? 1. Okay? So anytime I do my subtraction and I get a negative on the top, I have to move it to the bottom to make it positive. So therefore, this is equal to 1 over C, and then I write that as a +3. Okay? So anytime I have C to the -3, or anything to a negative power, I'm always going to write it 1 over whatever that is. So in this case, it's C to the 3. If it was x to the -8, it would be 1 over x to the -8. Okay? Listen very closely. If I start with a negative exponent on the bottom, where does it have to go to become positive? It'll have to go to the top. Okay? And it's not going to, the letter's not going to change, just the number will change to positive. Okay. So my rule is, anytime I have a letter with a negative exponent, I have to change where it's at in the fraction. So if it's on the top of the fraction, I have to move it to the bottom. If I would have it on the bottom, so this would be 1 over a to the -n, then I would move that to the top of the fraction. Do I need to write the imaginary one? No. Do you see what I mean? Nope, we would not be working on the imaginary one. Your goal in this lesson is to get rid of all of the negative exponents and then use all the other rules that we've already learned. The goal is to get rid of all of the negative exponents and then use the rules that we've already learned. Okay? I call this stay and go. Because I like to rewrite the fraction so all of my exponents are positive, and then I apply my rules that I learned earlier. Because it seems easier in my brain. If you always want to apply the rule where you're subtracting, get that negative and then just move it to the bottom, that's fine too. Okay? So let me show you how stay and go works. So 2 to the negative 4, if this were a fraction, would my 2 to the negative 4 stay on top, or does it have to go to the bottom to become positive? The bottom. It has to go. So then I have to put a 1 there to hold the place. So then I'd have 2 to the 4th. And what is 2 to the 4th, Paulette? You got it for me?
Yeah.
16. Does everybody know how Paulette's getting that so quickly? Everybody knows how to do that in your calculator? Okay. What about number 2? Is it going to stay or go? The j to the negative 4. Is my j to the negative 4 going to stay there, or does it have to go to the other position in the fraction? It's got to go, right? It's got to go up. And then it becomes positive. Once it goes, it becomes positive. To whichever location it has to go. Okay? Are these examples or worksheets? These are examples. Okay, so here's how I do this. N to the negative 5th, stay or go. So I write my fraction down, my fraction bar. Is my n to the negative 5th going to stay there, or is it going to go? Go. So I'm going to write it down below. Okay? P to the 4th, stay or go? Stay. R squared, negative 2, stay or go? Go. So it's going to go to the top and become R squared. That's my answer. Okay? You want to deal with each letter at a time. Numbers are divided like normal. So you may want to, if this helps you, sometimes this helps people, you may want to rewrite the problem so things are chunked out. Here I've got r to the negative 3, here I've got r squared, here I've got a t to the 7th, and oh, that's a 4, and a t to the 7th, and here I have a u to the negative 5. So this is something that I've taught people that seems to help them. Take it or leave it. You don't have to do it. It's just a method. But when you write that separation, rewrite the problem with that separation in there. It's a little easier to see because they're really close to each other. I know that. Okay? And then you can apply your rule. 5 and negative 20. What's my number going to end up as? How are 5 and negative 20 related? Where's the 4 going to end up? Top or bottom? Bottom. Why is the 4 going to end up on the bottom? Because that's where the bigger number is. Okay? That is another way that you can think about this. And we're going to talk about that when we do the t's. So, I divided both of them by 5. Yep, 5 divided by 5 is 1. Negative 20 divided by 5 is negative 4. Yep, so I reduced my fraction. Okay, now with my r's, pick if you're going to do the stay and go, or if you're going to do the rule. If you were going to do the rule, you would have r negative 3, what? Minus 2, right? So that's the rule. If you don't want to do the rule, then no worries. and do stay and go. Is r to the 3 going to stay or go? Go. R to the 2, is it going to stay or go? Stay. Yes. Everybody see that? We're just going to deal with the r's right now. So, what do I get? Eventually, you won't have to show all these steps. I'm just showing you lots of steps so that you understand it, right? Okay? R to the, so this would have been r to the negative 5, right? But it's negative here, so where would it have to go? To the bottom. Here, we put it into the bottom, and we have to apply this rule from last week, where we have to add them together. So it's r to the 5. Same math, just applying different rules, but we get the same answer, right? So I guess different math, but depending on which rule you like better. Does that make sense? And I have a thumbs up sideways for that. Okay. My t's, it kind of looks easier to apply my rule, right? I could subtract those. So here, listen closely again. Put your pencils down and look up here. Just like this, when I did my fraction, my 4 ended up on the bottom because my bigger number was on the bottom. What do we notice? What are we going to do with these two numbers if we apply our rule? Subtract, right? And theoretically, we're going to do 4 minus 7. But if you think about how numbers work, listen very carefully. If you think about how numbers work, you can go, oh wait, I can just do 7 minus 4, because 4 minus 7 is going to give me negative 3, right? Yes? But 7 minus 4 is going to give me 3. Wherever that bigger number starts, subtract the bigger number by the smaller number, and wherever the bigger number starts is where your answer is going to end up. Because if I had t to the negative 3, I'd have to put it in the bottom of it. Yes? Are you following me? So 7 minus 4 is 3. It started down there, so I can just do t to the 3. Do you see that? I'm actually going to put the 7 minus 4. And I'm able to do 7 minus 4 because of where I put it. So this is t to the 3rd. What's going to happen with my u? What's going to happen with my u in that problem? It's going to change. So where's it going to end up? Top. Right? So u to the 5th. I don't have any of it to combine with anybody, so that's my answer. Okay? I know it took us a long time to get there, but that's because I wanted to kind of explain how the numbers work and think about that. You guys want to try 3 on your own? Either do stay or go, or the rule. Pick a method, do the method. Pick a method and do the method, okay? So stay and go, and then combine using our rules from today and last week, or use the rule, subtract everything, subtract well, and write things in the right spots. All right, so let's look at number 4. I need to do my fraction again. I can divide both of these by 5. So 1 over 5. J. Any other J's in there? Nope. Where's J going to end up? Top or bottom? J goes a negative 3. Bottom. Okay. Where's A going to end up? 2 and negative 4. Huh? 3. And J to the negative 3 just moves to the bottom. J cubed. Okay, I've got k's, I've got 2 and negative 4. K will end up on top, and what's my number gonna be? Because this is gonna be k squared, and then if I move this up top, I'm gonna have k to the 4, so I'm gonna have k to the 6. What about my m's? Where's the bigger number, negative 6 or negative 2? Which number is bigger? Negative 2, because that way J owes me less money, right? I mean, so where's that going to end up? So if you did stay and go, your M would go to the top, M2, and your 6 would go to the bottom, right? If I did stay and go, 6 minus 2 is 4. Where's the bigger number? Bottom, so my answer is up over bottom. You see that? Jay, do that worksheet. Okay? Good? Do the worksheet. Comp English people, head up. All right, for the video, so my 1/5 came from my 2/10. And then my a to the negative 3 had to go to the top. So I had 2 plus 3 was 5. And my b to the 1 had to go to the top. So 3 plus 1 is 4. And my negative 5 had to switch with my negative 4. So I got c because 5 is bigger than 4. Okay.